Hi everyone, we are going to make a little scatter plot of some data. The data that I'm going to be using today is on page 96 on our Thinking with Math Models book, and I'm going to be doing this question number 1 where we are looking at height versus stride distance of people taking steps. In this, we need to ask ourselves very first, before I start actually creating the scatter plot, is either one of these an independent variable versus a dependent variable? Sometimes with making scatter plots, you truly don't have an independent variable or a dependent variable because you don't know if there's even a relationship between the data. This, though, I think we can sort of say one is going to be independent versus dependent. Do we have control over the height? No. We're gonna always have like a particular height that we're going to end up becoming. So I'm gonna say that is our independent variable, and our dependent variable is gonna be based on that height. Somebody who's really, really tall is likely gonna have a longer stride than somebody who's pretty short. And so we are going to put our height on the x-axis and the stride length on the y-axis. And after we create this scatter plot, we'll be able to see how this is all shaping up, and we can sort of do some questions on predictions and that sort of thing. Yeah, and now I'm gonna make my scatter plot. Bye. Okay, so as I'm doing this, I just set up my graph, and my graph looks something like this. A couple of things that I want to pay attention to with my graph. I put height on the x-axis and stride distance on my y-axis, but what I also did is right here in the corner is I created this little crunch. That little crunch means it tells you that from 0 to where you start your numbers, there's a whole lot of numbers in between. This allows you to tell the person who's looking at this graph that you have sort of zoomed in on a particular part of the graph, so that way you can graph something accurately, but still also be able to spread it out so you can truly see what's going on, but you've left out a ton of numbers that don't necessarily matter. We are not going to have a ton of data. If I look at this, my height data and my stride length data, they're in the hundreds. So if I look at my height data, I am going from, it looks like 146-ish centimeters up to 154 centimeters, 153 centimeters. And that is a lot bigger than 0. And for stride distance, we're looking at the same sort of thing. We're looking at numbers in the 120s and 120s. Yeah, pretty much. We're looking at numbers in the 120s. And so because of that, that also those are numbers far away from 0. If I were to create a graph without doing this little crunch, I would have nothing on a huge portion of this graph, and then a lot just right up here all clumped together, and it wouldn't allow me to see a whole lot. Instead, what I'm going to do is I'm going to fill up this whole graph, but I'm going to start my numbers here with like number 145, and then I'm going to go over a couple of units to 146, and over a couple of units to 147, and then 148 and 149, and so on, and really fill up this thing and this x-axis with numbers from, let's see, 146 to 153. I'm literally filling up with about 7 numbers, and I'm going to fill up this whole side with that, so that way I can truly see where this data is and I can really zoom in on it. Same thing on this side. I am filling up this side with numbers from 120 to like 127. So again, 7 units will take up this whole vertical axis, and I'm going to do the same sort of thing. Start with like 120, and then go up a couple of units to 121, up a couple of units to 122, and really allow myself to zoom in on this. It's super important that when you're creating a scatter plot, that you create a scatter plot that's actually usable, so that way you can really look at the data carefully. All right, thanks for listening to my little caveat as I start to create my plotted data and my scatter plot. We will talk again shortly. Okay, so here is my plotted data. If you look at my scale, I went by 2s along the bottom and along the top, so that way I could keep my scale consistent. However, I really zoomed in. I literally started at 146 and went to 156, and obviously my data stops at the 153 range. And same thing here, I started at 120 and I went to 130 and went up by 2s, and my data stopped in the 126-ish range. But I can really see and zoom in on my data. Again, if I had just plotted this on a graph that went from 0 to there and 0 to here without putting these little crunchy parts. If you don't put these crunchy parts and you create a graph that looks like this but without the crunch, you're essentially creating some really misleading data, or a really misleading graph. Regardless, these little crunchy parts allowed me to zoom in on this stuff, and I can now really see what's going on. If I hadn't done that, I would have had a little blob of stuff right up here, and I wouldn't have actually been able to analyze this. But what we can see now with this general data, when it comes to how tall people are versus how big their stride is, we can definitely see that there is a trend. As you get taller, your stride length tends to get longer, meaning you can take a bigger step, which that makes logical sense, right? But we can see in this data that there's a general trend that's positive that goes up that way. Now remember, this is real life data. So like somebody who, like, we can see a couple of people who have essentially the same stride length, but they all are different heights. They're just slightly different in height. We can see another couple of people who are the same stride length, but they are different heights. We have two people who are essentially the same height, but have different stride lengths. Again, this is real life data. There could be other extenuating circumstances that are like coming into play. Perhaps this person has a longer torso versus shorter legs, versus this person might have a longer set of legs and a shorter torso. So there's more extenuating circumstances besides just height that comes into play with stride length. But at the same time, we can still see generally that the data is trending in the positive direction. So it's coming up in general over time. Now, it's important that we are looking at this data and we're able to see it and zoom in. So creating this scatter plot and making sure that you're keeping a very consistent scale along the bottom is important, as well as along the vertical axis. That's important. And then also putting little crunchies here if you need to, so that way you can really zoom in on the data and really look at it clearly and make sure your reader of the data, or the person who's looking at your graph, is seeing something accurate, meaning these crunchies need to be there if you're going to be zooming in and getting so zoomed in on this data. It's important that we have a consistent scale also, so that way these data points actually are not just going to fall on a straight line completely, because again, this is real life. There's variability, which we can see by plotting it with this like 2 units each time for each of these data points. It's really important as well that we are labeling our graph. You can see height in centimeters versus stride length in centimeters written on the side. We can put a label across the top of this that says we want to call this height versus stride length if we wanted to, and actually put a title on this graph, which we should do, so that way that somebody looking at this could very quickly understand it versus having to decipher it from the labels on the X and Y axis. But this, ladies and gentlemen, is how you make a scatter plot. If I look at any one of these points, I should be able to decipher generally what these points mean. So I would be able to look at, say for example, this point, and I could go down on my X axis and say this is, I can't read actually because I'm not close enough, 151, yeah, 151.5 versus whatever number is over there. Can't read it, 124 or something. But I should be able to describe every single one of these points as an X and a Y coordinate pair that relate to the height versus stride length. Cool? Cool. All right. Thank you for watching. Thank you for making your own scatter plots in our must-do practice problems for this lesson. There's going to be one more video that talks about sort of interpreting this data and making some predictions based on this. And then we'll go from there. Thank you for watching. Bye.